Welcome to my channel. Let us assume today we gonna solve a numerical example by using Kuhn Tucker condition method. We will solve this numerical example. Max z is equal to 2x1 plus 12x1 x2 minus 7x2 square subject to 2x1 plus 5x2 lesser equal to 98 where x1 and x2 greater equal to 0. Let's start. First, we have to convert the inequality constant and into equality constant by adding slack variables and form capital Gjx. Since there is one constant, so we have to form only capital G1x. So let capital G1x is equal to 2x1 plus 5x2 plus s1 square minus 98 is equal to 0 where s1 square is the slack variables. So now we have to construct the Lagrangian function s1, which is a function of x1 x2. Since there is only one inequalities is therefore only one Lagrangian multiplier lambda 1 and one slack variable s1. So the is equal to the objective function. First we have to write the objective function, then minus lambda 1 into the capital G1x, that is minus 98. This is a Lagrangian function, and now we will solve by putting the Kuhn Tucker condition for maximization problem. So what is the first condition? The first condition is del L del xi is equal to 0. So first we will partial differentiate L with respect to x1, that is del L del x1 is equal to 0 implies 4x1 plus 12x2 minus 2 lambda 1 is equal to 0 implies 2x1 plus 6x2 is equal to lambda 1. I will numbering it by 1. And next del L del x2 is equal to 0 implies is 12x1 minus 14x2 minus 5 lambda 1 is equal to 0 implies 12x1 minus 14x2 is equal to 5 lambda 1. That will be number 2. Okay, next by second condition, a second Kuhn Tucker condition for the maximization problem, we have lambda 1 into 2x1 plus 5x2 minus 98 is equal to 0. From the second condition, the two cases may arise. One is lambda 1 is equal to 0. Next is lambda 1 does not is equal to 0. We will check both the cases. Case 1, lambda 1 is equal to 0. If lambda 1 is equal to 0, then 1 and 2 becomes 4 2x1 plus 6x2 is equal to 0, that is x1 plus 3x2 is equal to 0. Number 3, and 2 becomes 12x1 plus minus 14x2 is equal to 0, that is 6x1 minus 7x2 is equal to 0. Solving 3 and 4, we can easily get x1 is equal to 0 and x2 is equal to 0. So we have, in this case, x1 is equal to 0, x2 is equal to 0 and lambda 1 is equal to 0. So we will get this from the first two Kuhn Tucker condition, and we will check it the solution will satisfy the number Kuhn Tucker condition, the third Kuhn Tucker condition and fourth Kuhn Tucker condition or not. Okay, we will check number 3, the condition, third condition, that is the condition is jgx lesser equal to bj, or we can write here jgx is 2x1 plus 5x2 lesser equal to 98. This will satisfy if we put x1 is equal to 0 and x2 is equal to 0. This will satisfy the inequality. So third Kuhn Tucker condition is satisfied by the solution in this case. And what is the fourth Kuhn Tucker condition? Fourth Kuhn Tucker condition for the maximization problem is lambda j is greater or equal to 0. Since the value of the lambda 1 is equal to 0, so it will automatically satisfy the fourth Kuhn Tucker condition also. So they are all Kuhn Tucker condition for the maximization problem is satisfied by the solution for the. So we can write x1 is equal to 0, x2 is equal to 0 and lambda 1 is equal to 0 satisfies all the Kuhn Tucker condition, or in short we can write KT condition for maximization problem and it is a feasible condition also. It is a feasible condition also, that is x1 x2 all are greater or equal to 0. Okay, therefore in this case max z is equal to 0. It is a feasible condition. Let's the value of the objective function is 0 in this case. Either it is maximum or not, we will see later. Now case 2. Lambda 1 dash not is equal to 0. Since lambda 1 dash not is equal to 0, from the second Kuhn Tucker condition we will have, from the second Kuhn Tucker condition we will have x1 plus 5x2 minus 98 is equal to 0. I will numbering it number 5. Now solving, now we have to solve number 1 and number 2, then we will get x1 and x2 in terms of lambda 1 and put the values of x1, we will put the values of x1 and x2 in number 5, then we will get the value of lambda 1, and from the value of lambda 1 we will get we can easily get the value of x1 and x2 also. So solving, so we have to solve the number 1 and number 2. So for this 1 is multiplied by 6 and minus 2, we will get 12x1 plus 36x2 minus 12x1 plus 14x2 is equal to 6 lambda 1 minus 5 lambda 1, that is 50x2 is equal to lambda 1 or x2 is equal to lambda 1 by 50. Putting this value of x2 in number 1 we will get, putting this in 1 we get 2x1 plus 6 lambda 1 minus 50 is equal to lambda 1 or 2x1 lambda 1 minus 3 lambda 1 by 25, that is 2 lambda 1 by 25, or we can write x1 is equal to 11 lambda 1 by 25. So we will get x1, the value of x1 and x2, and now we will put this value in number 5. Putting these values in 5 we get 2x1, so 24 lambda 1 by 25 plus 5x2, that is lambda 1 by 10 is equal to 98 or 50, that is 49 lambda 1 by 50 is equal to 98 or lambda 1 is equal to 100. So we will now we get the value of lambda 1, putting this value in putting this value in x1 and x2, we will get the value of x1 and x2. So x1 is equal to x1 is equal to 11 lambda 1 by 25, so x1 will be 44, x2 is equal to lambda 1 by 50, that is 100 by 50, that is 2, and lambda 1 is equal to 100. So now we will check whether this satisfy all the Kuhn Tucker condition or not. First two is automatically satisfied. Now we will check the third condition is satisfied or not, that is 2x1 plus 5x2 less or equal to 98 or not. We will check 2x1 means 2 into 44 minus 98, it minus 5 plus 5x2 that is 10 less or equal to 98 or not. This is exactly equal to 98, this is exactly equal to 98, so this will satisfy the third condition. And what is the fourth condition? Fourth condition is lambda 1 greater equal to 0 for the maximization problem. Lambda 1 is clearly greater equal to 0 for the greater equal to for this problem. So this will satisfy all the Kuhn Tucker condition. The solution is satisfies all the Kuhn Tucker condition, KT condition, and the solution is feasible also. Since x1 is greater equal to 0 and x2 is also greater equal to 0. So, and for this case the value of objective function we can easily calculate by putting the value x1 is equal to 44 and x2 is equal to 2 in the objective function. We will get the value 4900. So we will check which value is the maximum from the both the two cases. We easily can say that this is the maximum value from between 0 and 4900. So the max date is, so the solution is x1 is equal to 44, x2 is equal to 0, x2 is equal to 2 and max date is equal to 4900. This is the solution. Thank you. If you have any question, ask me in the comment section.